Hello everyone, welcome to physics class for today. Chapter 9, Force and Laws of Motion. Okay, we will start the discussion of this chapter. We will discuss first force, what is force, what possible effects it can create on an object, and its laws also. Let's discuss force and laws of motion. Okay, we will study about force, balanced, unbalanced, and the three laws of motion. Let's start. Force. Force is either a push or a pull. Either it changes or try to change the state of an object. Okay, so force is an external effort which may move a body at rest or stop a moving body or change the speed of a moving body or change the direction of a moving body or change the shape of a body. Okay, so force is a push or a pull which either changes or try to change the state of an object. What are the possible effects of a force on an object? Force can move a body at rest. Okay, in the first pic you can see a person applying force to move the car on the forward direction from rest to motion. Force can stop a moving body. You can see a football goalkeeper trying to catch the ball from motion to rest. Force can change the speed of a moving body. You can see a bicycle rider will change or can change the speed of the bicycle by applying the force. Force can change the direction of a moving body. You can see in the next pic, a cricket player with his bat can change the direction by applying the force on the ball. Okay. Next or last is force can change the shape and size of a body. You can see in the very last segment, with the application of force, you can see the change in the size as well as in the shape of the floor while preparing the chapatis. Okay, let's study something more about force. Effects of force you can also see in this pic also. Okay, while applying the force on a spring, it can be stretched longer than its original length. Okay, can be dented when it is hit. You can see in the pic also with the hammer. Okay, and in other pics also you can see the sponge becomes smaller when it is squeezed. Okay, in the pics also you can see whether with the application of force the shape can also changed. So let's study about two types of force. One is balanced and other is unbalanced force. If two forces act on a body in opposite direction and if both are equal, then the resultant force acting on the body is zero. Such forces are called balanced force. Balanced force cannot change the state of rest or motion of a body. Got it? You can see in the very first pic, F1 is equal to F2. That means if F1 is equal to 10 Newton, then F2 will be equal to 10 Newton. And as a result of these two forces, there will be no change in the state of the object. It will remain at its original position. Unbalanced force. If two forces act on a body in opposite direction and if one force is greater than the other one, then the resultant force will not be equal to zero. Such forces are called unbalanced force. Unbalanced force results in the change of the state or state of rest or of motion of a body. Okay, you can see F1 is greater than F2. Reverse can also be possible. F2 can also be greater than F1. Okay, then the object will move in the direction of greater force. Okay, let's discuss something more. Force of friction. You have also studied about the concept of friction in class 8th also. Force of friction is the force which opposes the motion of an object over a surface. A ball rolling on ground gradually slows down and comes to a stop due to force of friction. If we stop pedaling a bicycle, it gradually slows due to the force of frictions and comes to stop due to force of friction. Okay, an object with uniform motion will continue to move with uniform motion if the force acting on it, pushing force and friction force, are balanced. If an unbalanced force acts on the moving body, then its speed or direction of motion changes. Okay, if the unbalanced force is removed, then it will continue to move with the speed it had acquired till then. Okay, it had acquired till then. Galileo experiment of motion of an object on an inclined plane. You can see in the pic, slope are there. The ball will fall from the top side and move on the other side top. Okay, when a marble rolls down an inclined plane, its velocity increases, and when it goes up on the second inclined plane, its velocity decreases. If the inclinations of both the planes are equal, then the marble will reach the same height which it rolled down. If the inclination of second plane is decreased, it will travel more distance to reach the original height. If the inclination of second plane is made horizontal, then the marble will travel forever trying to reach the same height. An unbalanced force is required to change the motion of the marble, but no force is needed to sustain the uniform motion of the marble. Okay, got it? Now, Newton's laws of motion. Every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. Okay, second law is force is equal to the change in the momentum m into v per change in time for a constant mass. Force equals mass times acceleration, F is equal to ma. And the third law is for every action there is an equal and opposite reaction. Okay, got it? Let's study all these three laws in detail. Now, Newton's laws of motion. Newton's laws of motion. Newton's first law of motion states that an object remain in a state of rest or in uniform motion in a straight line unless compelled to change the state by an applied force. Okay, which means the object will continue in its state until or unless some external unbalanced force is not applied on that. Okay, inertia, the natural tendency of objects to remain the natural tendency of objects to remain in a state of rest or in uniform motion, state of rest or in uniform motion is called inertia. That is why the first law of motion is also known as law of inertia. Okay, let's try to understand inertia in more deeper state. Inertia is the inability of an object to change its state by itself. Okay, inertia is of three types: inertia of rest, inertia of motion, inertia of direction also. Okay, let's study something more. Examples of inertia: if a striker hits a pile of coins on a carom board, the lowest coin moves out, and due to inertia of rest, other coins fall down. Okay, if a coin placed on a playing card over a tumbler is flicked with a finger, due to inertia of rest, the coin falls down into the tumbler. Okay, you have seen in the first slide in the pic also. When we travel in a car and driver applies the brake suddenly, we tend to fall forward due to inertia of motion. Okay, when we are standing in a bus, the bus begins to move suddenly, we tend to fall backward because our foot is in contact with the floor, moves forward, but upper part of the body continues to remain at rest due to inertia of rest. Okay, got it? You can see in the pic also. It will not move, the toy car will not move in the forward direction until or unless some external force is not applied on that. Okay, you can see in the next peak also, the car will not stop itself, the toy car will not stop itself until or unless some external agency will come in contact with to stop it. You can see in the last one also. Okay, inertia and mass. We know more will be the mass, more will be its inertia of an object. Okay, a body at rest continue to be at rest, and a body in motion continue to be in motion. This is the property of a body is called its inertia. Inertia of a body is measured by the magnitude of force required to change the state of the body. Force is required to change the state of a heavier body is more than the force required to change the state of a lighter body. This is because the mass of heavier body is more than the mass of lighter body. Okay, the mass of a body is a measure of its inertia because more will be the mass, more will be the inertia. More is the force required to move an heavier object with larger mass because F is equal to m into a, mass into acceleration. F is directly proportional to m. More is the mass, more will be the force, and more will be its inertia. Okay, so heavier objects have more inertia than smaller or lighter objects. Okay, momentum of a body. The momentum of a body is the product of its mass and the velocity. Okay, momentum mass is directly proportional to v. P is equal to mv, where p is the momentum of a body, m is the mass of the body, v is the velocity of the body. Okay, if a body is at rest, its velocity is 0, so its momentum is also 0. The SI unit of momentum is kilogram meter per second, kg meter per second. Okay, a truck moving at a low speed can kill a person standing in its path because the heavy mass of the truck A bullet of small mass, when fired from a gun, can kill a person because of its large velocity of the bullet. So, the impact of a body depends upon its mass and velocity. Got it? Clear from these two examples? Now, second law of motion. Second law of motion. Newton's second law of motion states that the rate of change of momentum of an object is proportional to the applied force in the direction of force. Mathematical formulation or derivation of the motion. The question in 3 marks generally comes derive the mathematical formula for force, okay, or derive second law of motion. If an object of mass m is moving along a straight line with initial velocity u and is accelerated to velocity v in time t by applying a force F, then initial momentum P1 is equal to mu, final momentum P2 is equal to mv, change in momentum P2 minus P1 is equal to m taken out common v minus u. Rate of change of momentum, it is m into v minus u upon t. Okay, got it? Then on applying force, F is directly proportional to m into v minus u by t, or F is equal to, we will remove the constant of proportionality over here, then it becomes F is equal to k m v minus u upon t. Okay, got it? V minus u upon t. But we all know from the first equation of motion, v minus u upon t is equal to a, because v is equal to u plus at. Okay, so from that equation, v minus u upon t is equal to a. So F is equal to k m into a, where k is a constant of proportionality and its value is 1. We can consider its value 1, or F is equal to m into a. The SI unit of mass is kilogram, acceleration is meter per second square. Okay, so the unit of force is kilogram meter per second square, or Newton. Its symbol is capital N. Now, the third law of motion. Newton's third law of motion states that to every action there is equal and opposite reaction, as they act on two different bodies. Okay, to prove that the action and reaction are equal and opposite, let's study. Take two spring balances A and B connected together. Fix the spring balance B to a rigid support. When the force is applied by pulling the free end of the spring balance A, both the spring balances shows the same reading. This shows that the force exerted by the spring balance A on B is equal but opposite in direction to the force exerted by the spring balance B on A. The force exerted by the spring balance A on B, action is action, and the force exerted by the balance B on A is reaction. In simple terms, both spring balance will show the same reading, which means the force exerted by both on each other is equal and opposite. Okay, got it? You can see some examples also. When a bullet is fired from a gun, it exerts a forward force that will be considered as action on the bullet, and the bullet exerts an equal and opposite force on the gun, and the gun recoils, that is reaction. Okay, you can see in the pic also, accelerating force on the bullet, action, recoil force on the gun, reaction. Got it? Now the second example, when a sailor jumps out of a boat, he exerts a backward force of the boat action it is called. Okay, the boat exerts an equal and opposite force on the sailor reaction and the sailor jumps forward. Got it? You can easily see or easily observe the action and the reactions in both the cases. Okay, see some more examples. When an air-filled balloon is released, the force of the air coming out of the balloon action exerts an equal and opposite force on the balloon is reaction and it moves upward. Okay guys, next is very important examples. Many times it is being asked in exams also. When a rocket is fired, the force of the burning gases coming out action exerts an equal and opposite force on the rocket reaction and it moves upward. Okay, got it? Force on hot gases, it is one type of force, action it is, and force on the rocket it is reaction. Got it? Got it, dear students? Let's move forward. Conservation of momentum, the most important topic of this chapter. In many cases or many times it comes in 5 marks. Conservation of momentum states that the sum of momenta of two objects before collision is equal to the sum of momenta or momentum after the collision, provided that there is no unbalanced force acting on them. Got it? This means that the total momentum of the two objects is unchanged or conserved by collision. Okay? Let's consider ball A and ball B, or two objects A and B having their masses MA and MB moving with initial velocities UA and UB. Okay? In first cases, this is the before collision case, and second is during collision, and third, you can see three diagrams are there. Third is after collision conditions. Okay, for first case, for collision to take place, UA should be greater than UB. Okay, and during collision both will exert force on each other. FAB and FBA will be the two forces. FAB and FBA are the force exerted by one on another and second on first. Okay dear students. Okay, during collision at time t, the ball A exerts a force FAB on B on ball B, and B exerts a force FBA on ball A. Okay, got it? If VA and VB are the velocities of the balls A and B after collision, the momenta of the ball A before and after collision are MAUA, MAVA, and for ball B, MBUB and MBVB. Got it? Initially, UA was greater than UB, and after collision, VB will be greater than VA. Now, change in momentum of the ball A during collision. MA VA minus MA UA. Final momentum of ball A minus initial momentum of ball A. Rate of change of momentum of ball A FAB. Okay, it is MA V minus U by T. Change in the momentum of the ball B during collision MBVB minus final momentum minus initial momentum mb minus ub, m taken out common. Then the rate of change of momentum of ball b, fba, mb is equal to vb minus ub upon t. According to Newton's third law of motion, FAB exerted by ball A on B will be equal and opposite to the force FPA exerted by the ball B on A. So therefore, FAB will be equal to F minus of FBA. Minus sign shows the direction of force. Okay, so MAV minus UA upon T is equal to minus MB minus MB VB minus UB upon T. It's not sign of bar over there. It is VB minus UB upon T. So T got cancelled out from both sides, and it is MA VA minus MA UA is equal to minus of MB VB plus MB UB. Do initial momentum for both on one side and final momentum on other sides. Okay, so it becomes MAUA minus MAVA minus MBVB. So from this it comes out MAUA plus MBUB is equal to MAVA plus MBVB, which shows that the momentum of two balls before and after collision is equal to the momentum of the two balls after. Okay, from this both the momentum of both the balls, sum of initial momentum is equal to sum of final momentum of both the balls. The total momentum remain conserved. Got it? The best thing to understand is derive this expression by yourself. Okay, derive it by step. Now, dear students, if any query, you can ask, you can put your suggestions. Okay, so two more important thing from this chapter is, it is the for derivation point of view, second law of motion, as well as conservation of momentum. Got it, dear students? So try to derive the conservation of momentum by yourself and ask. If there is any doubt, then you can easily ask. Okay, thank you, dear students. Take care. Bye bye.